We're going to look at how to rationalize the square root of a denominator, which basically means get the square root out of the denominator. To do this, we're going to use the property that when you multiply a square rooted thing by itself, it has the effect of just canceling out the square root symbol. We're also going to use some old rules from 4th grade about how to multiply fractions. So this first problem, 7 over the square root of 5, I do not like the square root being in the denominator, so what I'm going to do is multiply it by itself. But because I have to keep things balanced, I'm going to do the same thing to the top. Now I'm going to reach back into my old-timey 5th grade knowledge of multiplying fractions, which said if you have two fractions multiplied together, the top by the top makes the new top, and the bottom by the bottom makes the new bottom. Let's start with the bottom, because that's what got this whole thing going in the first place. I have a root 5 times a root 5, so I'm multiplying this thing by itself. The whole point of doing that was that the roots cancels, and I just have a 5 left. As far as the top is concerned, 7 times root 5, one's under a radical and one is not, so the best I can do is say that it's 7 square roots of 5. This will be my final answer. It actually does look a little bit worse, but the fact that there's no square root in the denominator is very good for what we want to have happen. The next problem, the first thing I'm going to do is break up that fraction over the square root like this. Now I see that I can't have the square root in the denominator. That's not allowed, so I'm going to rationalize it. I'm going to take this root 3 and I want to multiply it by itself so that the square root will cancel. But I've got to keep things balanced, so whatever I do to the bottom, I've got to do to the top. Now using rules about fractions, bottom by bottom is new bottom. So we have root 3 times root 3. Well, that's basically root 3 squared, so the radical cancels. We just have a 3. The top this time is root 5 times root 3. Unlike the previous example, these are both underneath the square root symbol, so it's going to be square root of 15. You might be tempted at this point to try to reduce this fraction, but because one's under a radical and one is not, you can't do anything with this. This is the best answer. The next problem, root 6 over root 54, these numbers are pretty big. If you see numbers this big happening in a problem, it probably means something's going on. You could probably do something first. And I happen to notice that 6 and 54, there's a common factor there. So I don't usually rewrite things this way, but I can think about the fraction like this for a second if I want to, and see if I can reduce this fraction. If reducing fractions is not like top on your list of things you love to do, I'll just remind you that we can just take the calculator out and do 6 divided by 54. And then instead of pressing equals, press this math button, choose the frac option, and it'll tell me that that equals 1/9. So this is the same thing as the square root of 1 over 9, which I can think of as root 1 over root 9. And look at this. Hey, these are both perfect squares. So that's cool. This becomes 1, this becomes 3. That's my final answer there. For this very last guy, it's kind of a combination of everything. I have here the square root of 10/15. I noticed right away there's a common factor here of 5. So you can follow all the steps we followed over here and get the correct answer, but you do want to be on the lookout for reducible fractions whenever you can. So something like this, where one ends in 0 and one ends in 5, right away I can see I can divide both of these by 5 and think of this as root 2 over 3. I can break that up as root 2 over root 3. Now, I don't want to have this in the denominator, so I'm going to multiply it by itself, but I've got to do the same thing to the top. Bottom by bottom is just going to be 3. The square root will cancel. Root 2 times root 3, they're both under a square root symbol, so I'll smoosh them together. 2 times 3 makes 6. Root 6 is my answer. Again, it might be tempting to try to cancel this 6 and this 3 and reduce it down, but because one number is under a radical and one is not, you're not allowed to do that. So they all can be a little bit different. They can all be a little bit like there's little tricks for each one. But as long as you think about reducing your fractions and making sure, using the property that multiplying a square root thing by itself kills the square root, and you use those properties for multiplying square roots appropriately, you'll get through these. Good luck. Be patient with yourself.